Think you understand time and space? These shocking facts about time, space, and the universe will make you question everything you know. We're going to be tackling some of the most profound questions that have puzzled humanity for centuries. From the speed of light to the existence of black holes, we'll explore the cosmos and unravel its secrets. So, buckle up, space cadets, and prepare for an awe-inspiring journey through the cosmos. Let's embark on this quest for knowledge together. Tell me why light has a speed limit. All right, folks, let's talk about the speed of light. It's the cosmic speed limit, clocked in at 299,792 kilometers per second. That's like circling the Earth 7.5 times in 1 second. Einstein's theory of relativity explains it. Space and time are intertwined in a cosmic dance. As you approach light speed, time slows down. At light speed, time stops. To go faster, you'd need to break space-time. Tell me why astronauts see the sun rise 16 times a day? Ever imagine waking up to a sunrise every 90 minutes? That's the reality for astronauts aboard the International Space Station. You see, the ISS is whizzing around Earth at a staggering 28,000 kilometers per hour. That means they complete an orbit every hour and a half, giving them a front row seat to 16 sunrises and 16 sunsets every single day. Talk about a spectacular view. Now, you might think that seeing that many sunrises would get old, but imagine the sheer awe of witnessing the Earth bathed in the golden hues of dawn, then plunging into the darkness of space, all within an hour and a half. It's a constant reminder of our planet's breathtaking beauty and our place within the grand cosmic tapestry. And who knows, maybe one day, you'll get to experience it for yourself. Tell me why the sun doesn't burn out? The sun, our very own star, has been shining brightly for billions of years. But have you ever stopped to wonder how it keeps the lights on? It's not like it has an endless supply of firewood up there, right? The sun isn't actually burning in the traditional sense. It's powered by nuclear fusion. Hydrogen atoms fuse into helium, releasing energy. Think of it like a giant cosmic pressure cooker. This process is incredibly efficient. But in about 5 billion years, the sun will run out of hydrogen. It will eventually die out. But that's a problem for future generations. Tell me why some stars explode as supernova. Now let's talk about the most dramatic way a star can go out. A supernova. These cosmic explosions are some of the most powerful events in the universe, briefly outshining entire galaxies. But what causes these stellar fireworks? Well, it all comes down to a star's life cycle. You see, stars are in a constant battle between gravity, trying to crush them inward, and the outward pressure from nuclear fusion in their cores. For most of a star's life, these forces are in balance. But when a massive star runs out of fuel, the core collapses under its own gravity, triggering a shockwave that rips the star apart in a brilliant explosion. These supernovae are not only spectacular light shows, but also play a crucial role in the universe's evolution. They scatter heavy elements, forged in the star's core, into space, seeding the cosmos with the building blocks for planets and even life itself. Tell me why we count time in 60-minute hours. Ever wonder why we divide an hour into 60 minutes and a minute into 60 seconds? Why not something more convenient like a nice round number like 100? Well, you can thank the ancient Babylonians for our timekeeping system. You see, the Babylonians had a thing for the number 60. They used a sexagesimal system for mathematics and astronomy, which means they based their calculations on 60 instead of 10, like we do today. Why 60? Well, it's divisible by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, making it a very handy number for dividing things up. And guess what? Their influence on timekeeping stuck around. So the next time you're staring at the clock, remember that you're looking at a system thousands of years old, a legacy of the Babylonians' fascination with the number 60. Tell me why black holes are invisible. Black holes, the cosmic monsters that lurk in the depths of space, are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. But if they're invisible, how do we even know they're there? Well, just because we can't see them directly doesn't mean they don't leave their mark on the universe. In fact, their immense gravity creates some pretty telltale signs. For example, as matter falls into a black hole, it forms a swirling disk of superheated gas and dust called an accretion disk. This disk can emit incredibly bright X-rays, which astronomers can detect. Moreover, black holes can distort the fabric of space-time itself, bending the path of light that passes near them. This effect, known as gravitational lensing, can create multiple images of distant objects, revealing the presence of a black hole. Tell me why Mercury experiences extreme temperatures. Mercury, the smallest planet in our solar system, is a world of extremes. It's scorching hot during the day, with temperatures soaring to 800 degrees Fahrenheit, or 430 degrees Celsius. But wait, it gets weirder. At night, temperatures plummet to a frigid minus 290 degrees Fahrenheit, or minus 180 degrees Celsius, making it one of the coldest places in our solar system. So what's going on here? Why the dramatic temperature swings? Well, the culprit is Mercury's almost non-existent atmosphere. Unlike Earth, which has a cozy blanket of air to trap heat, Mercury's atmosphere is so thin that it's practically negligible. Without an atmosphere to regulate its temperature, Mercury bakes in the sun's rays during the day and loses all its heat to space at night. It's like a cosmic oven that's constantly switching between broil and freeze. Tell me why scientists look for water on other planets. In the vast expanse of the cosmos, scientists are constantly searching for signs of life beyond Earth. And in their quest for extraterrestrial life, water is the holy grail. But why water? What's so special about this seemingly simple molecule? Well, for starters, water is essential for all known life forms on Earth. It acts as a solvent, transporting nutrients and removing waste within cells. It plays a crucial role in chemical reactions, and it helps regulate temperature. Moreover, water is incredibly common in the universe, found in vast quantities as ice, liquid, and vapor. So it stands to reason that if life exists elsewhere, it might have also evolved to depend on water. Of course, finding water on another planet doesn't guarantee the presence of life, but it significantly increases the odds. It's a beacon of hope, a sign that the conditions for life as we know it might exist elsewhere in the cosmos. Tell me why time travel is possible in theory. Time travel, a staple of science fiction, has captivated the human imagination for centuries. But is it merely a fantasy, or could it be grounded in scientific reality? According to Einstein's theory of relativity, time is not absolute but relative to the observer's frame of reference. Time can be affected by gravity and velocity. For example, time slows down in stronger gravitational fields. This is known as gravitational time dilation. As an object approaches the speed of light, time slows down for that object. This is known as time dilation. In theory, traveling at speeds approaching light or navigating intense gravity could allow for time travel. Tell me why the moon has no atmosphere. Our celestial companion, the moon, is a barren wasteland, devoid of air, water, and life as we know it. But have you ever wondered why the moon lacks the cozy atmosphere that we enjoy here on Earth? Well, it all comes down to gravity. You see, a celestial body's gravity determines its ability to hold on to an atmosphere. Earth, with its relatively strong gravitational pull, can retain a thick atmosphere. The moon, however, is much smaller than Earth, and its gravity is much weaker. In fact, its gravity is about 6 times weaker than Earth's. This weak gravitational pull means that the moon doesn't have enough oomph to hold on to an atmosphere. Any gases that might have been present during the moon's formation would have escaped into space long ago, leaving behind a desolate, airless world. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-bending content. See you next time. We've explored some of the universe's most intriguing mysteries, from the speed of light to the possibility of time travel. But remember, the cosmos is full of unanswered questions, waiting for curious minds like yours to unravel them. So keep exploring, keep questioning, and keep looking up at the stars. The universe is vast and full of wonder, and there's always something new to discover.